last time we were talking about two different color theories, additive and subtractive color theory. And the thing is, they're going to be working together because when we see something, we see reflected light, which means light coming from some source which is made up of the additive colors, and then it reflects off and was made using the subtractive color theory. So we need to be working together, or working with them together, I should say. So let's go back and remind ourselves about a few of the details. Number one, what we see, as I mentioned, is reflected light. Whatever you're looking at, unless somebody's shining a light in your eye, whatever we're looking at is light that has been reflected from that. And then colored objects are going to reflect those colors of light. So a red object, it looks red because red light is reflected off of it. That also means that the colors that are not reflected are going to be absorbed. So what we notice is the reflected color. Now we're going to keep things kind of simple, but think of all the different colors that you can see. You're seeing those colors being reflected. Combinations perhaps, but colors nonetheless. So I'm going to start with this magenta object. If I shine white light on a magenta object, I can get white light using three primary colors from the additive color theory, red, green, blue. And if I shine those colors onto, or if I shine white light onto a magenta object, magenta is the combination of red and blue. So if you go to the additive color theory, when I combine red and blue light, I get magenta, which means if magenta light is approaching my eye or entering my eye, then that means the combination of red and blue is going into my eye. So red and blue light get reflected from a magenta object so that I see it as magenta. And then there's my eye, receiving that magenta light. If I take exactly the same object and I shine yellow light on it, now additive color theory of light, yellow light comes from the combination of red and green. So red and green, I perceive that light to be yellow. But if the yellow light shines on that magenta object, magenta objects reflect red and blue and they absorb, they don't reflect green, which means in this case red light is going to be reflected into my eye, green light is going to be absorbed. There was no blue to be reflected, so all I get is the red light, and I perceive, I look at that object and I now call it, or I say it appears to be red. It's not red in white light, but because I was using yellow light, it's going to appear red because no blue light to be reflected. If I take exactly the same magenta colored object and I shine cyan light on it, I can get cyan light, additive color theory, from using green and blue in combination. Well, magenta objects reflect red and blue, but there's no red to reflect, so all that's going to happen is the blue reflects, the green gets absorbed, and I perceive, I look at that object and I say it appears to be blue. If I were to shine green light on that magenta object, well, green light does not get reflected, it gets absorbed, so what I would see is no light being reflected, and it would appear to be black, no light being reflected. Now, would it appear to be a true hard black? Probably not, but it would appear to be black. It would not look magenta or green or blue or red. It would look black, no color, no light being reflected. That is pretty much how we're going to approach everything. Now you're going to be getting different colored objects and shining different colored lights on them, hopefully you're for real, but if nothing else, then as, at least on paper. And you should be able to do exactly what we just got finished doing, identifying what colors are going to be shining on it based on the color of light, what colors are going to be reflected based on colors of light being reflected. You're going to be combining additive color theory and subtractive color theory, and it's just doing what we just got finished doing. Anyway, talk to you another time.